Hi guys, today we're going to talk through the power law of logs. Now, in my first video, we've seen that if you had 2 to the x is equal to 64, then in order to find x, you would have to say it was log to the base 2 of 64. Now, as a mathematician, I have a bit of an issue with how that's set up, in that I've lost something from this side and I've gained something on that side. So when I'm solving any sort of equation, I always aim to keep things equal by doing the same thing to both sides. So I need to sort of explore here how I could do the same thing to both sides. So let's start again with 2 to the x is equal to 64, and maybe if I need to take a log to this side, I ought to take logs to both sides. Okay, so now as a mathematician I'm happier because I've done something to the same to both sides to maintain that balance idea that we have when we're solving equations. So what that means is that somehow this here is going to come to x. And one way that we can consider it is that this x, because of the rules, this rule of log, the power law of logs, can come down to here. So we could have x log 2 is equal to log 2 of 64. And this here, if I'm saying what power of 2 is 2, has an answer of 1. So this is x times 1 is equal to log 2 of 64. So that gives me x equals log to the base 2 of 64. And hopefully that makes a bit of sense. Now, more primitive calculators, if you were still using one of those, they might not enable you to find log to the base 2. In fact, most calculators up till fairly recently have used log to the base 10 or log to the base e, which we spoke about was ln. Right, I'm going to do the same problem here, but I'm going to use a different log. So I've got 2 to the x is equal to 64. This time I'm going to use, well, we've introduced e, let's use that log to the base e. So I'm going to say log to the base e, or the natural logarithm of 2 to the x, is equal to the natural logarithm of 64. So similar here, I took log to the base 2 of both sides. Here I've taken log to the base e of both sides, the natural logarithm of both sides. Now that's okay. Then this power law says that I can bring this down to here. And so I get x ln 2 is equal to ln of 64. Now I don't actually know what the value of ln 2 is, and neither do I know what the answer to ln 64 is. The answer to this one here was 6, of course. But coming to here, that's not easy to work out, and that's not easy to work out. But still, being a good mathematician, we are thinking, okay, if I divide both sides by this ln, because the x is times in it, then I can maybe find out what x is. So ln 64 divided by ln 2. If I grab my calculator and bang that in, ln 64 divided by ln 2, and I do indeed get the answer of 6. Hopefully you can see that. So this is a rule that starts to break away from us needing to be able to work with a particular power or a particular base. So this is log to the base 2, this is log to the base e, and we can use any power, any base, because the maths behind using logs works the same. So say I said something a bit less standard, so let's say 3.5 to the x equals 19. If I take a ln to both sides, or I could take a log to base, let's go log to base 10, because that's a common one. It doesn't matter what log you use. So log to the base 10, 3.5 to the x is equal to log to the base 10 of 19. I'll use that power law to bring this power down. I'm going to say x log to the base 10 of 3.5 is equal to log to the base 10 of 19. So x is equal to log to the base 10 of 19 over log to the base 10 of 3.5. And that comes to, let's put it into my calculator, log to the base 10 of 19 divided by log to the base 10 of 3.5 equals 2.35. Three significant figures. So that means 3.5 to the power of 2.35 roughly is equal to 19. I just want you to check if instead of using log to the base 10, I'd use log to the base e. So that would be ln 19 for ln 3.5. Let's have a look at that. ln 19 divided by ln 3.5 again equals 2.35, or maybe if I'd use log to the base 2, log to the base 2, 19, whoops, not log to the base 219, divided by log to the base 2, 3.5, again 2.35. So it really doesn't matter what base log you're putting in. From a simplicity point of view, log and 2, so that's 1 press, 2 presses, and then the number. Log to the base 10, log, a 1, and then a 0, so that's 3 presses and then your number. But ln is just 1 press, 1 button, and then the number. So ln 19 divided by ln 3.5 will give you the answer. But the important rule is here that if you take a log of a value, then this power can come down and multiply at the beginning. And I've used that every single time. And that's really, really useful. Okay?